Welcome back, guys. So today's question is pancake sorting. In this question, we'll be given an array and we have to sort it by performing some flips, and we have to output the flips we have performed. I'll explain it what I said in a bit, but let's see what are the constraints in the array. So what are the constraints is like array can have elements from 1 to the length of the array. So what I mean by this is, suppose the length of the array is 3. Okay, so what it means is, like in the array we can have elements as 1 2 3 or 3 2 1 or 2 3 1. I mean, any permutation of 1 to 3 can be the possible input. Okay, so now we have understand the constraints. Let's move on to the explanation part. So I forgot to tell you one thing, that suppose we are performing a flip from this position, then what we have to do is we have to perform it from 0th index to that position. So by performing a flip, I mean reversing the array from starting to that position. So the array will be like 3 4 2 5 1 after that flip, and 5 1 won't be flipped. Okay, so now by looking at the array, what we can say is we have to bring 1 to the 0th position, 2 to the first position, 3 to the second position, 4 to the third position, 5 to the fourth position. So let's say we are first we are bringing the first number 1 to the first position, that is 0th position. So what we can do for that is we can perform a flip from 0th position to the 4th position. So array will be like 3 5 1 5 3 4 2. So this part of the array is sorted down. Now we can look at the left part. So in this part we have to put 2 to the first position, I mean the first index position. Okay, so what we can do is we can flip from this position to this position, from one index to the fourth index. But in the constant it is given that you always have to flip from 0 to that position. Like if you are flipping from here, from the 4th, then we have to perform the flip from 0 to 4th. Or if we are performing a flip from 3rd index, then we have to perform 0 to 3. So if we take 1 initially, we can't form an answer from it. So let's try it with 5. Let's first take the largest element of the array. So what we can do is we have to bring this to the end, but we can only perform the flip from 1 to that position, 1 to 3. So let's try flipping it first. So what will the array will be like? A 5 3 4 2 and 1, right? And after that what we can do is we can move this to the ending position, right? So now there will be like 1 2 4 3 5, and now we haven't violated any of the constraints and this part is sorted, right? So now we'll look for the next largest element and do the steps again, like bring it to the first position and then bring it to its original position. So let's erase this for the timing. So we had the array like 2 4 3 5 1. So after performing the first flip from this position, it will be like 5 3 4 2 and 1, and from this to this it will be 1 2 4 3 5. Right, so we have sorted this without violating any of the constraints. After that, what we can do is, the next largest element is 4. We can move it to the front by flipping it 4 2 1, and in the next flip it will be 5, not 5. We have to move this to this position, right? So we'll flip it from this position, from 0 to this position. So there will be like 3 1 2 4 and 5. Now these two positions are sorted, and we have to look for this position. So now we have to move 3 to here. So we'll find the next largest element, that is 3, and we'll continue the process, and at the end we'll get the array like this. And in the output array, what we have to fill is, the output will be a list of integers. So what we have to do is, what we have to fill in the output array is the position we have flipped from, every positions. So the first we have flipped from the third position, but the output expects the answer as 1 based indexing, so we'll push 3 plus 1. And the next we have flipped from the last index, 4 plus 1. So the output will be like 4 5, and the every flips we performed, right? So now let's go and do the coding part. Initially I'll have the output list created, and I'll return that at the end, and in between I'll have my logic. So what I'll do here is, I'll traverse the array from the end, and I'll skip the 0th position, because at the end the element at the 0th position will always be sorted, and we have to find the index of the max element from 0th index to the ith index. After that we have to flip it from 0th index to element, and we'll add that index to our output list, and after that we have to flip it again to its sorted position, that is the ending position where the I is, and we'll add that position to our output list again. Please ignore the background noises. Now we'll create the helper functions. So initially I'll assign the max to the lth position, and I'll traverse the array from L plus 1 to R, and find the max there. Then we'll update the max to I. So at the end we'll have the maximum, the index of the maximum value, and we'll return that. And for the flip function, so we have to flip it from 0 to the R index R. So what I'll do is, left will always be 0 and right will be, which will be passed from here, flip. So we'll just reverse it. This is tuple reversing in C#. I think this is similar to the reverse in Python, the sort and reverse technique. So what we can do is array at the left and right position will be moved, will be swapped. Yes, so this will reverse it. Let's check if this runs or not. So you can see it's accepted. So according to the question, there can be multiple solutions, so output can differ. Let's see if it's get accepted or not. So yeah, it does. Thank you for watching. Do like and subscribe. See you next time.